So welcome, it's June, we're halfway through the year. Longest day of the year is what, in 3 days? Oh, yeah, it's on, yeah. Thank you. Yeah, almost the longest day of the year, and then days start getting shorter. First, thank you for last month's last-minute craziness. As probably you know, my wife, I had to take her to the ER to deal with something, and so luckily, Jim had brought his computer. I emailed him the file. The good thing is we found out this building has video projectors, which I didn't know. That was always been my fear if something happens, we don't have a video projector. Computers and mailing files around is easy, but so they have projectors here, so if something ever happens and this is not here for whatever reason, we can still have a meeting, so that's good. But thank you, Jim's not here, but I want to thank everybody for stepping in. And I got a question, so I asked it earlier, but I'm going to ask it again. My trivia question, what was the first music video that was played when MTV first signed on? And the ironic connection of the title and the industry. Somebody got it. They said somebody got it.
Video killed the radio?
Correct. Yep. So I didn't know how that went over or not, but I know it's a little fringy and maybe a little younger, but
what was the answer?
the music was the video killed the radio star by the Buggles. But it was the first music video that MTV played, and the song prophesized the death of radio because of video, which was accurate, right? So.
Gosh, I even do that one.
Okay, so since we're on to trivia, what was the predecessor, direct predecessor to the 8-track tape?
4-track, 7-track. By Madman Months.
Okay, I'm going to have to start getting harder questions. That's correct.
I had one chrome plated in my 56 Oldsmobile with little 12s in the trunk and crossovers and clean 20 watts per channel.
A whopping 20 watts, huh?
Yes, and it was really amazing.
Talking to back to
Yeah, really.
And you could buy that thing, the pinch wheel came up into the cartridge, the same size as the 8-track cartridge. And it's basically a cart machine.
it worked like
Like the cart machines, yeah. Yeah.
And you could change, tracks with a little lever. It had bass, mid-range, and treble on it, all chrome plated. And you could buy an album, I still have one, by Peter, Paul, and Mary, and put it on top. And play a whole album, or you could buy singles. I used to go to J.C. Penney's on the south side of Chicago and buy singles, a little small cartridge.
Mm-hmm.
Song A and B.
How big were the cartridges?
Same
Same
size,
size.
exactly the same
As an
size as the 8.
Yeah. Oh, wow.
But they were better because they had more bandwidth and everything. They're actually a real tape in a cartridge.
Yeah, because didn't actually, or maybe the 8-track, one of them changed where they actually started to pull the tape out, or did that one pull the tape out?
They all did the same.
They all did, okay. Yeah, well, yeah.
Yeah, which is basically a Betamax is a scaled down, great big giant video machine used in broadcast.
Yeah.
U-Matic.
Pneumatic, right, 3/4 inch.
Scaled down U-Matic.
Yeah,
But now none of these pulled them out.
they
They were just,
were just like they are, straight,
And
okay.
they
the
were
only
better
difference
than
in
the
this one was
VHS.
the H roller came up out.
That's what it was, okay.
It was like,
Would
I
the
was
8-track fit inside the 4-track? Would it play it?
No, because the pinch roller's made in the 8-track. And on the 4-track, the pinch roller's on the machine and swings up into the cartridge.
I've got a machine that does both. It plays 8, or you can push the lever and then pop a pinch roller up into the thing.
Yeah, and I've got a Radio Shack one that plays 8-tracks and quad things.
Yeah, my understanding was, I guess that was the complaint about the 4-track was that the pinch roller was in the machine, and the people who came out with the 8-track, which was Mr. Lear Jetman.
Well, the reason 8-track came out, you get more songs.
Well, yeah, but then he wanted the pinch roller in the cartridge, was my
You get
understanding.
more crosstalk and everything else with 8.
Oh, you don't care, it's 8-track, you're 16, what do you care, you know? Anyway, okay, well, good. I've seen pictures of that, I still don't understand how,
45 players in the car, I couldn't put them in when I was a kid.
I don't know how that works.
Along with reverb, bring you back down.
Okay, the agenda. We don't have any minutes from last time because they weren't taken, so there's nothing to send out, so we'll just assume everything's wonderful.
There's another question for you, trivia. Do you know why it was called Mad Month?
Yeah, because he would sell crazy crap. It was like the Crazy Eddie in New York.
That's not it.
That's what I read.
That's not
Tell
it.
you what,
What?
Because he'd buy up all the overrun parts from other television set manufacturers and somehow cobble up television sets made out of all these different parts, and he would get some of he'd have to get some of the components separately, but my father in Phillipsburg, New Jersey, was servicing television sets in the late 40s and early 50s, and those immense television sets were just cobbled up with all kinds of parts from everybody, and you could look at all the components and you could tell who it was that this was supposed to be used
He
in.
was a brilliant engineer.
He was.
But here's another fact, too, is he made one thing that really made him a madman, is the fact that he made the Gutless Wonder. Because compactrons came out in your tube jack, you couldn't figure out how it worked.
Mm-hmm.
Because it didn't have enough tubes. Yeah. I said, this can't work. This is mad.
Well, now that was, Compactron came out in 1960.
Yeah, but he made that TV with the compactron series filament. I got shocked to heck with one of those.
And it really pissed RCA off. RCA didn't like being done by that. And they wouldn't call it the Compactron. If you look in a tube manual, they call it a duodecar.
Yeah, you got what, 3 and 4 tubes in an envelope.
Yeah.
You got your damper, your horizontal output, and everything
Mm-hmm.
in one tube.
Yep.
The tube jockeys said, this can't be. You know, same thing when the solid state come out, they had to put sockets in
Yeah,
because the tube jockeys were perplexed.
yeah,
They couldn't figure it out.
yeah.
So I even got a kit one time, I still think I might have it from Motorola, that had all the transistors and labels and what socket they went in for tube jockeys.
Yep. Actually, my Zenith 7000 Super Radio, the transistors plug in. That one. Okay, so no minutes. We'll go through old business. This is going to be a pretty short meeting overall. The new business will be Paul and the financial update. Then Paul's going to give a presentation. We'll have a quick break. We'll have our member project club input section. Show and tell, which is homebrew radios. And then, of course, the sales thing. So, we're up to 120 members on Facebook. Not too shabby. Not too shabby at all. So, that's the old business. The new business is Paul's going to do a real quick recap of sort of how the swap meet went and where we stand as a club financially. But before we do that, shame on me, I would like the 2 new members to stand up and introduce themselves. They joined at the swap meet. So go ahead, you can go first.
I'm Joseph. I've kind of been self-teaching myself how to restore old tube radios, and I'm about 3 or 4 deep now, but I have a lot more of a backlog. But I saw that y'all were here local, and I wanted to be part of the community.
Good.
welcome to the club.
Yep.
Hey, I'm Scott Banks, actually here last month, but I retired in October.
But see, I wasn't, so I have an
That's
excuse.
right, so I'm introducing myself to you again. I retired back in October and trying to amp up my hobbies. I had my ham license, and then I got the transoceanic bug, so I've got 4 or 5 transoceanics. One I'm gonna start playing with.
That's a gateway drug.
I'll play one of my ham buddies because he's like me. He's got about 4 or 5 of them too. So we fight over the ones we see at the ham fest. So yeah,
What's your call?
Whiskey Alpha 2 Alpha X-Ray Bravo was my dad's call.
Okay. I said, that's a pretty old call, so
Yeah, probably like
50s?
no, probably like mid-60s. I would say, yeah.
Okay. Paul's back up. Oh, before I do that, so Eric is here. If you don't know, he's our new treasurer. He's taking over from Paul. They're in the process of transitioning that now as we speak, connecting.
We're going to do that this week.
Okay, good. So,
There will be a couple of stages. We've got to get to my place and go through everything. And when we get all our ducks lined up, we go to the bank because I don't want to go to the bank without, and have to come back, go through all this baloney. So we're working all that, and when we do, Eric will transition and have that responsibility. And I hope to be around to support him any way I can if questions and when they come up. So,
yeah, that's the beauty. Paul's not going anywhere, and he's still got to get the donuts. It's the most important role, right?
well, that's one thing we gotta work out. Who has
Oh.
the credit card?
Handing that off too.
Okay, I see how this works.
I'm still gonna do the audio and the donuts, but he's gonna have money.
Understood. Okay, so with that, I'm going to swap presentations here, and Paul's going to explain to us, and I don't know what the heck VT Fuse was. I was debating what to do about that, but I just left it and figured you would explain it. So, I'd like to present Paul Hart. He's going to talk about VT Fuse. I think that's a new drink, made by Coca-Cola, I don't know. And so with that, Paul, the floor is yours.
Thank you. I did a version of this at the event we had in March 5th, 2022. This is because Sam Leisinger, who was going to be the member of the month this time, at the last minute was unable to do it. We decided to throw this at you. Yeah, I've always got something in the barrel if you need it. Anyway, this is an exercise in the Wayback Machine. Most of us I was a little kid during World War II, but I still remember some of the radio broadcasts about what was going on. But most of the American public really didn't understand why and how it was that the United States and the Allies were gaining an upper hand in the war as fast as we did. And the answer is we had it figured out before it all happened. And that's part of this story. And the point is, the seeds of that defeat of the Axis was already sown before the war ever started. And part of this is how that happened, and two elements that were critical in the war effort. There were all kinds of things that were critical in the war effort, but two of them were the development of radar, and some people have said that radar won the war, the atomic bomb finished it. And the VT fuse that had a level of secrecy applied to it that rivaled that of the atomic program itself. These two things I've given other presentations about all different aspects of World War II, the Western Electric and other manufacturers and their efforts during the war. At any rate, I'm going to hit on the development of the organization that allowed us to really get after this, and then radar, and then the VT fuse. Go ahead for the next one. This is a listing of the environment that led up to World War II. In 1922, Mussolini rose to power, and if you've spent time in your history, Mussolini was Hitler's model. And in 1931, the Japanese army invaded Manchuria. The emperor did not even know they were going to do that. The Japanese military was so in charge of what went on in Japan that this happened, and they ended up in the war without the government of Japan even knowing it. In 1933, Hitler became Chancellor of Germany. Germany seized the Rhineland in 36. The 36 Spanish Civil War occurred. Japan formally invaded China in 37. And you look at this, Chamberlain at Munich, Peace in Our Time, 1938, Anschluss in Austria, and 1939, Germany invades Poland. War declared, and Germany temporarily neutralizes the USSR. Go ahead and do the next one. This is a picture of Chamberlain at Hendon in 1938, coming back with the Peace in Our Time, which of course lasted for, 6 months. Go ahead, next one. In the United States, there was a tremendous anti-war sentiment because of the hangover from World War I and the fact that we were in a heavy depression. Let Europe fight its own wars. Lindbergh was the chief spokesman for the America First movement. And I'll tell you a little bit about Lindbergh in a minute. Political scene was bitterly divided between anti-war activists, interventionists, and President Roosevelt. And there was a gradual evolution of a dark American realization that the U.S. would be involved, like it or not. Next one. Lindbergh in Germany, 1938. Lindbergh is an interesting character in U.S. history. He had a family and a bride in Germany and had 3 children. It also, he was enamored of the regimentation and the competence of the German Air Force and the German military, and was trying to keep the U.S. out of any conflict with Germany. Now, here's a case of him being decorated with the Service Cross of the German Eagle in 1938. He had very close ties with Germany. And the kidnapping of his son and all that, in history, he was actually implicated in some of that himself. But he finally got a measure of rehabilitation because of his service in World War II when it did occur. But Lindbergh is, Lucky Lindy and all that kind of stuff, the great guy and his wife doing the round the world trip and all that. I mean, this guy had a very, very complex history. Go ahead, next one. Some of the most gifted scientific minds in the U.S. had been paying close attention. And this is a list of the ones that I have considered to be the most important. Ernest Lawrence, director of the Berkeley Radiation Laboratory. At this point, early on, there was a lot of science and a lot of experimentation going on in atomic physics, and this was the center of it. It wasn't the only place. Arthur Compton was an atomic physicist. Vannevar Bush was the president of Carnegie Institute of Washington. James Conant, president of Harvard University. Carl Compton, president of MIT. Frank B. Jewett, president of the National Academy of Sciences, Bell Telephone Laboratories, and Alfred Loomis, and I'll tell you something about him, possibly the most influential genius that nobody had ever heard of. Go ahead, next picture, next slide. This is a picture of Lawrence, Compton, Bush, Conant, Compton, and Loomis together. It's a very famous photo taken out in California in early 1940. These guys could see it coming. They knew that in order to be able to combat both the Germans and the Japanese, that was going to happen. They didn't know how or when. They knew we were going to have to be prepared. And so they set about creating a proposal for an organization to manage the U.S. war effort. Go ahead, next slide. This is a recognition of the challenges. The issues in World War I, they had the branches of the military, the Navy, the Army, everybody, they wanted control of everything. They wanted to determine what weapons were going to be made and who got them and all this and who paid for what. And there was all kinds of clashes and competition between the branches of government, military, and industry. And Britain is the only other country that was involved that really had this organized. Hitler liked to put his people together in competition with each other. And as a result, there was a lot of lost value to their work. They needed to develop an organizational map to manage the national developments. International conditions were rapidly becoming more dangerous and urgent, and of course that chart of those events showed that. The atom had been split in Germany December 1938, and U.S. microwave radar development had stalled. Radar is a defensive weapon, not an offensive one. And as a result of the fact that the Japanese and Germans were the aggressors, they didn't really have much emphasis on radar. But this is one of the major factors in our victory in World War II. Go ahead, next one. This is Alfred Loomis. Loomis was a brilliant man. He was a lawyer. He had degrees from Harvard and Yale. He had all kinds of background in the physical sciences. He was a financial genius as well. And he and his brother had a company, and they could see the Depression coming. And they had a whole bunch of investments. And the stock market had gone crazy, and in 1928, they transferred all of their assets to gold. So when the Depression hit, they had millions of dollars. And not only that, they had the ability, because they had the money, now they could buy up all the companies that were really good companies, and their stocks had gone to nothing. So these guys created a whole structure. And what he did was he purchased a mansion in Tuxedo Park, New York, where he built a world-class research center. In that part of New York, Jews were not even allowed to be roam around freely and be part of the populace. There was a tremendous amount of anti-Semitism. And what he did was he would bring Jewish scientists. Albert Einstein wasn't one of those. Einstein came in 1933. But the point is that he brought a whole bunch of these research people over from Europe. And in Tuxedo Park, he built this research center. And he assembled some of the world's most noted physicists and engineers, first in atomic physics and then radar. His genius was a major factor in organizing the efforts necessary to develop and implement some of the most significant weapons that we had in World War II. Go ahead, the next one. He was a catalyst unifying the best research and scientific minds in the U.S. He knew all these guys in the photograph. He knew all these guys could see it coming. They just didn't know when and where, and they said, we got to be ready. So they put together a single 4-page paragraph sketch of the proposed agency. The National Development Research Council was developed and presented to Roosevelt by Vannevar Bush. Roosevelt had been Secretary of the Navy in World War I, and he had seen the divisions between the different areas of the government and the military. And he knew it was destructive. So a single-page paragraph was presented to Roosevelt by Vannevar Bush. After 10 minutes of explanation, on June 12th, 1940, FDR said, put OK FDR on it, put it back to him and said, go do it. The military charged that it was a power grab by a small band of scientists and engineers. And Bush, who really didn't give a damn, said, that's exactly what it was. That's what they needed to do. Go ahead, next slide. This is the first organizational chart that expanded as the war continued. Bush was the head of this, and they had these various divisions, and the microwave committee was headed by Alfred Loomis. The radiation laboratory at MIT was headed by Lee Dubridge. What had happened at this point is that the only way that they really understood how to develop really high frequency power was with vacuum tubes, and about 700 megahertz was about as high as they could get. And it really wasn't enough to make a good radar that would really reach out, and anywhere near one good enough to do targeting. Anyway, at this point, Loomis and the microwave committee had been, you know that radar was invented in Britain in 1935, but it was more of a curiosity than anything else. They really didn't have the option to I can't remember the name of the guy that first detected it. Anyway, this is the first of the organizations, and you can see the numbers. The names that are in here are, a lot of them were on that chart before. Go ahead, the next one. In September 1940, Britain was being bombed. France had surrendered. The Low Countries were in German hands, and Britain stood alone. The British economy and industry were reeling from the war demands. Winston Churchill ordered that Britain's most valuable secrets be handed to the U.S. We were spending a lot of money and giving a lot of aid to Britain, but we really weren't sharing a lot of the details of our technical advances. And Churchill knew that if they were ever going to win the war, the United States had to get involved. And up to that point, it had been one of these, you show me yours, I'll show you mine kind of thing. And it was a very dicey arrangement that was occurring between the U.S. and Britain. But Churchill said Britain's most valuable secrets had to be handed to the United States, because they knew they couldn't produce themselves into a victory against Germany, let alone Germany and Japan both. Sir Henry Tizard was tasked to accomplish a technology exchange with the U.S. Next slide, go ahead. This is Tizard. I've never found a picture of Tizard where he was smiling. He organized this technical and science commission known as the Tizard Mission. He was the rector of the Imperial College of Science and Technology. He had been a visionary in advocating cooperation with the U.S. in development of radio location of aircraft, which of course is radar. Go ahead, next one. This is a quote from James Baxter, the official historian of the Office of Scientific Research and Development. The Tizard mission brought about 20 specific items of science that had occurred in Britain. And this is a quote that talks about the magnetron. When the members of the Tizard mission brought one to America in 1940, they carried the most valuable cargo ever brought to our shores. Go ahead. This is a drawing of a cavity magnetron. This was brought to the United States in 1940. This unit had traveled 3,000 miles and not been tested for 2 months. Loomis was the head of the radar program. And when Tizard brought this over, he had a meeting in his apartment and his facility in New York. The Brits were saying that this thing could produce an amazing amount of power. And, you know, you could put it in your hand. And they said, you guys, you got to be crazy. And so they said, okay, Bell Labs has a facility out in Whippany, New Jersey. At this time, Whippany was way out in the country. Today, Whippany is just wall-to-wall everything as we know it all over the place. And they took it out to Whippany, New Jersey, and it delivered an estimated 10 kilowatts at 3 gigahertz, which was absolutely unheard of. Now, one of the most curious things about it is this, everybody knew about the magnetron. I mean, Britain had developed this and made it work and do this. The Germans, the Russians, the Japanese, they all knew about magnetrons that had been discussed in the international scientific community. But nobody had ever made it work like this. Now this, if you count them, there's 8 cavities, and it was later discovered that the drawings provided for a 6-cavity version. They had not brought the intended sample. The labs duplicated the 8-cavity version and immediately began scaling it to replace their power source for the CXAM radar. So you can make these things bigger and get kilowatts of power down at 700 megahertz. And now you had a real radar. And not only that, the fact that they had this amount of power at 3 gigahertz was just absolutely revolutionary. So the entire radar effort in the United States just exploded. So some codes of these magnetrons were actually operating down as low as 600 megahertz, but most of them were at much higher frequencies. Go ahead. Western Electric immediately started reproducing and scaling the magnetron. Meetings were held to bring essential elements of industry together to exploit the capability. Huge number of new technical issues were encountered, like when you transmit and you got a pulse of 10 kilowatts and you got a sensitive receiver right next to it. How do you keep from blowing up the detector and the receiver while you're doing the transmission? That's a story in and of itself that Bell Labs worked through. But one of the interesting things is that Loomis had a meeting in his facility in New York. And he had RCA, Raytheon, Sperry, General Electric, all these people. And he sat them down. This was like the second week of a month of October, I think, in 1940. And he laid out, you got to do the IF, you got to do, and each one of these parts of the development around this had to be done. And he said, what do you think? And they said, well, we can give you an estimate of cost at the end of the month. Loomis said, I want hardware by the end of the month. And he got it. That's the kind of urgency there was associated with this. The radiation laboratory was developed as an addendum, as a part of MIT under Lee Dubridge, Bell Laboratories and Western Electric activities. Western Electric wasn't particularly happy about the fact that the primary development of the radar went to MIT and the Rad Lab, but as it turned out, they developed some of the most incredible radars that were used in World War II, and the Russians were using copies of them up into the 80s. Next slide, go ahead. This is, okay, now we're back to the political end of it. FDR signing the Lend-Lease Act, March 11. This marked the end of the United States neutrality. I mean, when you come right down to it, that's what it amounted to. Go ahead, next one. So now they created the Office of Scientific Research and Development. The NDRC was a civilian agency, had created detailed organizational structure. I showed you the basics of that. The OSRD was created by executive order by FDR on June 28, 1941. Do you see where these dates are going? It was a federal agency subsumed to the NDRC, and its structure, Vannevar Bush was the director, reporting only to FDR with virtually unlimited access to funds. James Conant became head of the NDRC, and James Conant was the president of Harvard. This is a book written by his granddaughter using records from his personal files about all this, because a lot of these people would come to Conant's home and sit around and talk about this stuff, and Conant would keep notes and they would make decisions. Go ahead, next slide. This is Vannevar Bush. He has to be, you look at his face, and he's a Midwesterner, and his attitude was, I don't care. This is what we got to do. We're going to do it. Get the hell out of my way. This guy had PhDs in electrical engineering from MIT and Harvard jointly. Those of you who were here when I did my member of the month thing, my mentor was John DeRemus. He had masters from MIT and Harvard as well. And people will say, well, that's impossible. And you say, I also know and keep contact with his son, and he did not know until just a couple of years ago that his father had those diplomas. He had amazing contributions to science and technology, and the New York Times said a master craftsman at steering around obstacles, whether they were the technical or political or bullheaded generals and admirals. And so this guy is an American genius and visionary. Go ahead, next slide. This is the Office of Research and Development. Vannevar Bush, Conant, 19 divisions, and the one that we're going to look at in more detail is Division 14 radar. And he had all of these. There was a British branch, an Australian branch. The primary focus was in the Rad Lab in Massachusetts. Go ahead. Yes?
Go back to the previous slide, the question. So now the NDRC had grown to 19 divisions?
Yes.
From the time, the first slide you showed us that it had like 5?
Yeah.
4 or 5?
And actually, the BT Fuse thing was became one of the divisions.
Oh, wow.
It was Division T. But we'll talk more about that later.
And the other slide was from what year, do you recall, that had just maybe the 5 divisions?
Oh, that was the original.
That was March of 41. This is June of 41. So it accelerated pretty quick.
So yeah, so I was wondering just what the time
Oh, yeah.
was and how it grew.
I mean, once Roosevelt signed off on it, and these guys had all the money they could spend to start and bring together all these activities. They could fund programs, they could build buildings, they could do research, they could do all kinds of stuff. And so you can see what's happening. This whole structure was getting put together before the war ever started for us.
Foresight.
And that's the genius of this whole thing. And that carries all the way through to the atom bomb project, to so many other projects that the U.S. used to its advantage in World War II. Because if you're going to produce tanks, you need to develop a design for a tank you want and then make thousands of them. Anyway, is that where you wanted to go? Go ahead. And by the way, anybody wants clarification or through this, you're welcome to raise it. October 9th, 1941. Look at the date. Franklin Roosevelt orders Dr. Vannevar Bush to move forward with a top secret project that led to the world's first atomic bombs. Over the following 4 years, the Manhattan Project was shrouded in secrecy despite more than 100,000 people working on it. Then, the day of infamy. President Roosevelt officially approved the project to make the first atomic weapons. But the point is the structure, the basic research facilities, the direction. If you read the book Oppenheimer, which is yay thick, I don't know how many of you have seen the film. The point is the effort was monumental. And I don't know to the extent that you've ever been involved in thinking about this. The atomic scientists were in a race with Germany. They thought the Germans were going to develop the atomic bomb before we did. And so when Germany was defeated, they said, we can stop. We don't have to do this because the Japanese aren't going to have an atomic bomb. Nobody else is going to threaten us. We need to stop. This is going to be a terrible weapon. And the government said, do it because we're going to use it on Japan. And these guys were devastated. That wasn't part of what they wanted. But here's a case where the political end of the decision-making wasn't with the scientists. But isn't that the way it is a lot of the time? Anyway, here you go. January 42, Roosevelt officially approved the project. Go ahead, next one. Okay, now let's go back to radar. This is an early radar system. You can see it was down, like the radar system that detected the attack coming in on Pearl Harbor was at 200 megahertz, I think. And they saw the airplanes coming in, but they didn't know what they were. They thought it was a group of B-17s coming in from the mainland. Anyway, this was the primary radar deployed by the U.S. Navy operating on 200 megahertz. It was a huge antenna bed spring, even though obsolete. Many were still in service in capital ships at the end of World War II. The USS North Dakota had one of these systems on it, and they continuously, through the war, resisted having it upgraded because no enemy damage ever occurred to that ship. And they figured the radar was, they weren't going to let anybody screw around with anything on the ship. Anyway, go ahead. Next one. This is the kind of fire control they had. They had people up on this thing with all of the antenna array in front of them. I mean, it was just an incredible mess. You can imagine doing this in inclement weather and all that good stuff. Go ahead, next one. The history of radar is unbelievable. As a matter of fact, when the war was over, the Rad Lab published a 28-volume account of what happened during the World War II in the development of radar at the radiation laboratory. So you can imagine that any review of what was going on has to be just a tiny fraction of it. So what I want to show you is the real key. This was the SCR 584 tracking radar with conical scanning. Development of the radiation laboratory, and the idea was Loomis's. And what it amounts to is normally you got the antenna rotating and you got the transmitter receiver in the middle of it. The idea was to make it do this all the time. It was rocking. And what it did was give you a much better resolution of the target such that you could use it to shoot guns with. And the best compliment, Bell Labs' acknowledgement of the superiority of the 584 over a radar that Bell designed that was pretty good for its day, but wasn't anywhere near as good. If you look at this, you got a power generator, you got the tracking radar, you got a gun predictor. This was done by Western Electric, and there's a story about that. I have the 8-volume summary of science and engineering in the Bell system. And they tell you in the beginning of one of these volumes that we don't usually talk about dreams in the Bell Labs, you know, but they said, we're going to tell you the story of one. And they show some of the documentation of it. What it amounts to is there was a young engineer who was working on some sort of a tracking system for ticketing of phone calls. And it had a bunch of potentiometers, big potentiometers that would rotate. And these guys didn't know anything about radar or the military. And the guy went to his lab director and he sketched out his idea for this. And they said, oh, how about this? And he said, I had a dream. And he said, what? He said, the dream was I'm in a trench. There's a war going on, there's airplanes flying, and there's a gun. At the end of the trench, I can see a man operating a piece of equipment, and he's got a gun. And every time the gun fires, he hits an airplane. I mean, 1 in 100 would normally do that. And he said, the man motions to me and to come to where he was. And he walks down there, and he looks, and the equipment that the guy is using is based on this guy's research, this potentiometer, this concept that he has. And he tells his lab director, and his lab director says, we got to look at this because we could do all kinds of predictions with it. So they worked on it for a couple of days, and then the lab director went to his boss and said, we think we got something. And he said, holy mackerel, we're in a research thing about gunnery. We could use this. The M9 gun predictor was a vacuum tube. There was 166 tubes in it. That was the gun, was the computer that was the interface between the tracking radar and artillery. And this predictor computed the gunnery with Sperry and all the gyros and everything to operate this, and the tracking radar and the results from the tracking radar. And so the radar locks onto a target within the overlapping part of a revolving microwave beam, and then the M9 predicts the target's future position and angles the gun accordingly. And this predictor, by a dream of D.B. Parkinson, is where that came from. And complete sets rushed to break the stalemate at Anzio in 1944. At this point, the capability was so secret that there was nothing in the public about it. Were they stuck at Anzio for so long and all of a sudden broke out? And the reason was this gun predictor. The Anzio people were getting interdicted by German air power, and they couldn't move. This broke the back of the Nazi attacks on Anzio and allowed the breakout to occur. There's very little about that ever written in history. Go ahead, next slide.
Now, Paul, was that shell that was shot by that gun, whose angle was predicted by the thing, did it have a BT fuse in it?
Later on it did,
But not at that.
but not at this
It was
point.
still just a dummy.
I
It
will,
was just shot.
I will give you one step further, and that is in the Second Battle of Britain with the buzz bombs, it was, and that's what broke the buzz bomb attacks. Anyway, but we'll get to that later. The SCR 584 gun-laying radar was extremely effective and supplanted the Western Electric SC 545. General Electric Chrysler redesigned the antenna mount for mass production used with the Western Electric M9. It was extremely effective, used widely in the Second Battle of Britain. And this is the brain trust of the Rad Labs pioneering gun laying radar. Lee Davenport and Ivan Getting, and an Army colonel who looks very nervous. Just 2 years later, the radar proved instrumental in shooting down the V-1 buzz bombs aimed at London, and at that point, both the VT fuse and this radar system were highly secret, their capabilities. Lee Dubridge has got to be one of the genius minds behind making this all come together and work. Go ahead, next slide. So here is a photograph of an M9 anti-aircraft director with a power supply, tracking head, and servo-driven 90mm gun. Here these guys are operating this system, and they were on this chart, this platform that actually rotated. In combination with the radar, it was unprecedented accuracy in anti-aircraft gunnery, and this was even before they had the VT fuse. Go ahead. This is the radar mounted on a trailer. Go ahead. Western Electric M9 gun director, and you can see these guys.
What were they seeing inside?
I'm not real sure. I could tell you what they were looking at, but they were.
In other words, was it like a CRT and they were both making the two things crosshair?
I don't know. I don't know exactly how it was done, but these guys were managing the data and deciding when to shoot and when not and all that good stuff. Go ahead. So during the war, there was an enormous number of different applications of radar. This is a Bell Labs WECO naval gun director. The antenna on the left, operating at 10 gigahertz, rocked up and down to obtain height information for low-flying aircraft. That's this one, and you could, I think it was this one actually that was doing this constantly. If you see World War II movies and you see the ship with these things doing this, that's what that was. Combination mounted on an M37 director was very effective. By the end of the war, U.S. designers and manufacturers developed an enormous variety of specific application radars. Go ahead, next. This is one of the most incredible things you've ever seen. This is a submarine radar operating with an antenna that the submarine could just come up close to the surface but not surface and actually scan. And the only thing that was visible above the water was this rotating antenna. And boy, did the Japanese have a hard time finding these things. The interesting thing is, it was 2 to 3 feet above the water level. And when you think this thing has to rotate, okay, now the submarine's got to submerge, and it's got to go down to what, 300 feet in World War II? The gland has to keep the water out. This thing has got to rotate when it's on the surface, and it's got to, and General Mills and Western Electric together figured out how to make this happen. It's just incredible stories, one after another, more than you can even conceive of, about the unity and the purpose in pursuing this war. Go ahead, next. And Armin's influence of radar on the course of the war. All this mainly used by the U.S. Navy. Every radar ever put on a U.S. submarine was made by Western Electric. Radar neutralized the German U-boat threat. You know, it used to be the German submarines in the North Atlantic could surface at night and recharge their batteries, not with B-24s, with radar. And the Germans would be on the surface charging batteries, and here comes a load of bombs. And they didn't know where the hell it came from. And so that broke the back of the German submarine activity. All kinds of stuff. By 1945, most of the U.S. electronics industry had been converted to production of radar equipment. was a lot of other stuff. And during that time, when you think about AT&T and the telecommunications industry, all the new plants that were being built, the factories, all the stuff that was put together, the Bell system and the telephone industry had to build telephones, switching centers, new transmission lines, all kinds of transmission facilities. It would have been impossible if this hadn't been supported with all that activity. Go ahead next. Okay, now we're going to go to the VT fuse. This is Dr. Merle Tuve, wartime director of the Applied Physics Laboratory at Johns Hopkins University. Tuve and Bush were both Midwesterners. They were high school buddies. They actually were screwing around as kids together. They were buddies and they were communicating with strings and cans and all this kind of stuff. This guy was a genius in his own right. He said, I don't want any damn engineer telling me how to make it cheaper. I want to know how he can make it faster. And that was the way it went with this guy. Go ahead, next slide. The variable time fuse. It's an old idea to have a smart artillery shell that could detonate when it came within a specific distance of the target. Early British development with rockets was included in the Tizard exchange, development assigned to Dr. Merle Tuve, Section T of the NDRC, August 24, 1940. You see, these guys were planning and getting ready for what they knew was going to happen. And they transitioned to an OSRD contract with the Applied Physics Laboratory. And the first Navy contract was in July 1942 for this thing. But the Navy was a problem because they always wanted to keep it secret. And the only way they wanted to use it was over water. So an enemy couldn't get an example of this thing and duplicate it. Go ahead. Now just think about the problem. This is 1940. If you're going to create a shell and it's going to have electronics in it, you got to have a vacuum tube. There's no way in 1940 to do it any other way. The firing creates a 20,000 G load shot coming out of the barrel. And it rotates at 500 RPM. It's got to must withstand extended storage in high temperature and humidity. It's got to be impervious to accidental detonation. It's got to automatically detonate the shell when 10 to 70 feet from a target object. And vacuum tubes are required. It's 1940. The entire program was under crushing secrecy. Go ahead now. This is what it looks like. This is the result of Mark 53 VT fuse. Now again, there were versions of this that were made for all the guns that the Allies had practically. I think there were 25 or 30 different versions of the shell. And you can see this is out of a military previously secret thing. This is a result. Battery chemical type G load. What it amounts to is the battery was a chemical battery. But the battery wouldn't work until the chemicals were brought together. So the 20,000 G broke the membrane between the two parts. So they came together, but it still wouldn't really work until the rockets, until the shell started spinning. And that put the chemicals right where they needed. And of course, at that instant, the battery is developing voltage and the vacuum tubes and the electronics are lit. By the way, well, let's go. The idea is the rotation forces the electrolyte to the battery plates. Voltage is applied to energize the electronics and charges a firing capacitor. This is an autodyne that transmits a 200 megahertz signal. What it amounts to, it's transmitting this 200 megahertz signal but it's also got a detector. And so when it gets close enough to an object, some of it's going to be reflected back. And when it's reflected back, they compare the reflected signal, they put the reflected signal against the transmitted signal, and they could see the differences. And those differences were the trigger, and when the differences got to be a certain level, it fired an amplifier, fired a thyrotron. The thyrotron fired through this sequence the detonator, and the shell exploded. Target gets closer when it reaches a specific trigger, is a thyrotron. 4 or 5 vacuum tubes are each 1/3 the size of a cigarette. The filaments had to be welded under a microscope. And people say, oh man, the tubes in those things, we could use them in hearing aids and everything. Now wait a minute. The life of the electronics was about 5 seconds. And the design of the filaments was to last for 30 minutes maximum. Okay, so can you imagine the amount of technology and work that went into building these things? And the first ones were made, go ahead, next slide, by, all of a sudden I can't remember, Crosley. The Crosley company built the first ones of these. And this is the key element that nobody thought possible. Everybody thought, the Brits, the Germans, the Japanese, they all figured if you could build this thing, it would work. But nobody could build the tubes. Nobody had the tubes. And this is interesting facts about the proximity fuse tubes. And here's one of them. You can see the tubes are in here, and this is all the battery stuff and all the rest of it. The filaments had to be welded under a microscope. In 1942, Sylvania bought a plant in Mill Hall, Pennsylvania to begin manufacture. They were putting out 50,000 of these tubes a month. Other manufacturers also made the tubes, but Sylvania was the only source that could provide required quantity and quality. Crosley was the first contract manufacturers, other later. Life 5 hours, I'm sorry, 5 seconds, 5 hours. Go ahead, next slide. Here's an exploded diagram of the fuse where you can see here's the transmitter receiver, here's the amplifier, the thyrotron, washer, energizing, washer, rear fitting, holding, all this stuff through, and here's the detonator that when the thyrotron figures it explodes the shell.
So Crosley made the whole thing, not just the vacuum fuse.
Well,
What this is showing.
this is the final assembly that Crosley made. I'm sure these various groups, there were a lot of other companies involved in this.
Okay.
And, but I think Crosley was the prime contractor for the first ones that were made. And they had, and the first ones had regular batteries in them. They had, and some of the tests they did, they would, down in Florida, they wanted to see whether or not it would be possible to jam them. So what they did was they took a B-17 up and they fired live shells, but they fired them way behind the bomber. And so what they would do was they would experiment with transmitting a lot of 200 megahertz energy toward where the shells were, trying to detonate them, trying to see if they could defeat them, if the enemy knew that that's what was going on. That's one of the reasons it was so secret, because they didn't want to figure out how to counter them. So anyway, you can imagine doing that with all the regulations that have been applied today, firing live shells at an actual bomber with people in it and hoping to miss. I hope these guys had parachutes. I mean, the stories just go on and on about this program. Go ahead, next. Originally restricted for use over water to prevent any enemy capture. Navy was the initial financier, and they didn't like the idea of using them over anything but water. Fear of jamming duplication deployed in England defeated that with the 584 radar is what killed the V-1 buzz bombs, but there was nothing they could do about the V-2s. Eisenhower insisted on deployment at the Battle of the Bulge, and it decimated German troops. What it amounts to is you could use these things over land. You fire the shell, you set it for 60 feet from an object. You fire it, it comes down 60 feet above the ground. It explodes and just blasts the whole ground with shrapnel. It decimated the German troops in the Battle of Bulge. Patton labeled it the funny fuse, credited it with the German defeat at the Battle of the Bulge. It's another piece of history that's not well understood. Post-war testimony, Germans had captured, the Germans had run over a storage depot with these shells in it, and they didn't know what they were, and they blew them up. But it was too late in the war anyway, but still, this is what they were afraid of. Go ahead, next slide. This is a picture of a barrage of VT fused shells fired over land. And you can see that the terrain is curving, and these shells were all intended to explode a certain distance from the ground. And you can see that the explosion patterns follow the terrain of the ground underneath them. Anyway, that just shows you how effective they could be. Go ahead. That's it. So anyway, I don't know if anybody else has got any questions, but these stories, you can imagine how involved you can get in this stuff when you start to do research, because you go from one thing to another, obscure sources, but in my past history, I testified in a lot of hearings, and I always felt that I had to be able to defend myself, and I would be willing to support any of this stuff with you, with research that I've done, and provide sources if anybody wants it. It's a fascinating set of subjects, and it's just amazing what we accomplished as a country with these guys with the foresight ahead of the war to develop the organization that led us generally to have a pretty well-directed and organized effort in the war. And that is why, as I started out, this is what doomed the Axis before the war ever started. Appreciate it. Thank you.
Thank you, Paul. Very interesting. I mean, I had never heard any of this stuff. Never. You know, I was under the impression that Pearl Harbor happened and then the next day switches were flipped, which is partly true, but no idea that all of this work had been done on the front end. And to his point about technologies driving technologies. You look at the armed stuff we have now, the laser guided this, the GPS, we go, wow, that's crazy. They can do that, but they're doing a microchip, right? They had to bolt together, vacuum tubes, which didn't have any of the capacity that we have today, and it worked. And they got it to work. And the thinking outside the box, a lot of the stuff we have now, in my opinion, is improvement of old theories, which just made it better, faster. Right? They had to invent the theory. Who would ever thought you could bounce a radio signal off of a piece of metal and find it? You can do it better now. But they had come up with the first math and science to do that. So very, very impressive. Thank you very much. Like I said, Sam had a kind of last minute cancellation. And I said, well, this is going to be a really short meeting, because I can do this presentation. I didn't know what a VT fuse was. He gave me no insight, so I literally had no idea. I saw the word radar. I figured it had something to do with radar.
Well, you can imagine Eric made that presentation a while back about software-defined electronics. And the contrast between that level of technology and what these people were dealing with, it's like, you know, you can imagine in 1940 saying we gotta build a vacuum tube that'll withstand 20,000 Gs and 500 RPM of rotation, and the only way we can do it is with a filament. And the filament, you would expect
It's gotta be that big.
it's got to be really.
We were lucky to have so many geniuses on it to begin with.
And
And of
everything's
course,
got to fit
Crosley,
this area.
And they were smart enough to pull them all together.
right,
Yeah.
and Crosley, of course, being in charge of things like vacuum tubes, he was a radio genius to begin with.
Well, actually, I have never been able to know for sure who actually figured out how to build the tube. It was either Raytheon in Ipswich, Massachusetts, or Sylvania in Salem, Massachusetts, yeah. But they were all working on it, but Sylvania was the only one that could ever build enough of the tubes and have a good enough record of it, of failures.
And they would all have to be hand assembled,
And
50,000 in a month, and hand assembled is unbelievable.
And they, by the time they were done, they were putting out 50,000 complete shells a month. And you know, that's 5 tubes each, plus all the rest, and there's, I mean, the idea of being 1940 and being faced with this problem, the genius of these people, and not only that, the whole function of bringing that all together and making it work and getting those results is just an incredible story. And that's one of the reasons I'm so interested in it.
Crosley had huge manufacturing capabilities, though. Yeah, there was radio, but they made all kinds of appliances.
Yeah,
They made refrigerators, stove, I mean, if it was electrical, they make it, you know, so it's.
What-
I was just gonna say, I love his story. The way I heard it, his son wanted to get a crystal radio or a radio, and it was too highly priced, so he thought he would come up with his own company versus buy one. And then he came up with his own radio station that was 500 to 750,000 watts that started blowing out even Canada. Just his story is amazing all by itself. Just
Was that WLW in Cincinnati?
Yeah.
Yeah.
Fascinating place.
Just down the street from the Voice of America at one time. Yeah, me and David and Charlie went and visited one time.
Oh, yeah?
Yeah.
Yeah. Oh, I still have this on.
Give tours there anymore.
Yeah, no, there was nothing that, we were just able to stand outside the fence and look at the transmitter. Of course, back, you know, the tower is still there.
One of-
But David Martin did talk us into the Voice of America, the guy gave us a tour there. He just pushed the little buzzer at the gate, told the guy, we were some radio collectors from Georgia. We were on our way back from Elgin one year. We got the grand tour.
Can I tell you one more of my favorite stories about this? When Bell Labs was working on the radars, they were having trouble with capacitors, because if you're working at gigahertz, a capacitor has got to work pretty fast. And they just were at a dead end. They couldn't get capacitors to behave. And one of the lab directors said to one of the engineers, "Do you know anybody over at DuPont?" And that guy said, "Yeah, I got some contacts over there." He says, "Why don't you call them and see if they got any ideas?" So the guy called him and he said, "Have you guys worked on any plastics, anything like that?" And the guy says, "Yeah, but we shelved the whole project." And he says, "Well, what was it?" He said, "It was a plastic that we were going to put cigarette packs in." He said, "The problem is the plastic was so hard that you couldn't get the package
You
open.
couldn't open it.
So you couldn't open it, so we just put it aside." And he said, "Well, can you send me over some samples of the stuff?" And he said, "Yeah, we can do that." And he says, "By the way, what did you call it?" And the guy says, Mylar. That's just one of hundreds of stories like that are just amazing. And part of this whole, the more you read, the more you get into this, the more incredible it is. And that's why I love talking about it.
Just sort of next month when I get up and do my little presentation thing, I went to work for Beckman Instruments when I got out of school. And Dr. Beckman, the guy that started the company, he had invented the pH meter. And in 1940, he wasn't happy with the controls that, you know, the potentiometers that he could use. So he invented the helipod.
Oh, really?
And in 1940, the guys that were running the secret MIT radiation labs got in touch with him because they were interested in his helipod to be used in the radar. And so he had to design a version for them and ramp up manufacturing. So he bought another company to manufacture those in quantity for the radar, the radar research and, of course, manufacturers going on. So it's interesting how all of this stuff ties together.
There's another story of all this intersection that was going on and all this cooperation. Can you imagine doing all that without the internet?
Oh,
Yeah.
You know, without
The other
the
thing,
search tools we have today.
Was there any percentage that didn't detonate, or was
oh,
it
yeah, well,
always?
sure, yeah.
Yeah.
The,
Well, and that was Mark 53 that you showed, the diagram. You know, there was Mark 1 through Mark 52 probably,
Oh,
you
yeah.
know, in developments that had some kind of problem or whatever, and
Well-
they refined it.
Well, not only that, but the different mark numbers were for use in different sized weapons. The British.
Oh, okay, I wasn't
artillery
thinking
was
about that. I was just thinking about versions that
Yeah.
didn't quite work like they wanted them to.
They had them, they had them for mortars, they had them for 105 millimeter artillery pieces, you know, all kinds of stuff.
And the Mark 7 is the photon torpedo of choice in Star Trek. Go check it.
Anyway, one of these things, I showed a picture of an American submarine in dry dock during the war, and there's 3 antennas on it, and they're all radar. And this was 1944, and the top one was just a little stick. It was a 10 gigahertz sniffer, because before the submarine would surface, they put that up. And if there was a Japanese airplane or a ship or anything anywhere, they didn't know where it was or anything like that, but they also knew that the enemy couldn't receive a 10 gigahertz signal, so they could never be discovered, and if they got any returns, they stayed submerged until they could get up. Stuff like that in 1944. It's just incredible. Absolutely astonishing. And the others were target locating and directing. One of them was for anti-aircraft, and the other one was for firing torpedoes.
It wasn't the Dark Ages.
Well, the whole story is just fascinating because it makes you wonder, could we ramp up and duplicate
No.
today? Because we don't have the, seem to
We
have
don't have the manufacturing base. You
Yeah.
know, we don't have the expertise.
Yeah, it's
You know,
all
yeah.
part of it.
Well, I disagree with some of that. We do have some manufacturing, we do have some expertise.
We have some,
The
Yeah,
government.
but nothing on the order of what we had back then.
Yeah.
Well, we, the collective we, or me and you?
I'm just talking about the number of machinists, the number of people that know how to do that kind of physical work. Of course, maybe we don't need it, you know.
I think we have regulations that would stop us from doing a lot of things today, too.
in politics.
Well, that shooting live bombers probably wouldn't fly.
Yeah, that would, probably don't.
There's more stories like that.
Yeah, they, well,
Yeah, I can
they'd
tell
have to
you
bomb
that
Oshawa first, and
Proximity bomb.
then they could get away with it.
Well, not only that, but today, the scope of things like warfare with biological stuff, I mean, all kinds of things that you,
That didn't work out well.
well, what I'm saying is we are in a different world. This is what I say when I do this, say, let me take you back in time. And it's like, you know, the cartoon, was it Mr. Perkins or Peoples or whatever it was, in the Wayback
Oh,
Machine.
Peabody.
Peabody, yeah, Peabody. Go in the back in the Wayback Machine. That's what this is. Anyway,
And we have no idea what's out there today.
Oh, yeah.
And it would be delivered by drones anyway.
Well,
There wouldn't be
the American public didn't have any idea what was going on
No,
with
they
a lot of
didn't
these
either,
stuff.
right, yeah.
Well, they didn't know about the SR-71 or the stealth fighter for decades.
Right.
Yeah,
Any other questions for Paul? Thank you again, Paul, A, for stepping in, and B, for a very interesting presentation. Let's take a 15-minute break, and we'll come back with, what do we have next? Our club, if you got an idea, got a question, project, interactive session, and then we'll do the show and tell. All right, everybody, let's go ahead and get started.
She had already arranged with someone else to get it back together.
This is the member project club input section that had been suggested and adopted from last year. If you're not familiar, it's an opportunity for members to say, I have a project, I got an issue, I need some whatever on X, Y, Z, and that the expertise in the room can provide valuable counsel to said person's challenge. So does anybody have a project or thing that they're working on, stuck on something, that they need some advice, the local resident experts? Anyone? Anyone? Bueller? Yes?
Well, I was gonna say, I've got one. I'm working on a process set that's in a white kind of thing like cabinet. And on the swap meet, and I apologize, I'm bad with names and things until I get to know you. But there's a gentleman there selling the dial, like the reproduction dial covers. And there was like these little rivet kind of things that's on there. And I guess, what's the best way to even do those rivets when you do a replacement dial glass and everything? It's like these little pop things that holds it on.
I know what you're talking about.
I was able to get mine out and reuse them. I don't know if you could do that.
Did you get the new rivets from Mark when you bought the dial-ins?
Well, he didn't have my dial ins at the time. I haven't sent him an email yet. It's been kind of hectic. But he had the little tool to reinstall them.
Right.
But then I'm kind of wondering the best method of popping those out there without maybe cracking the bakelite of the case itself.
Well, so is that dial-ins not attached to a metal bezel?
No, I think if I remember correctly, I think they've got it riveted in directly into the plastic.
I've never seen that. Does the plastic stay with the chassis? If you pull the chassis out, does the plastic come with it?
No, it's got the chassis.
It stays in the
Yeah, it
cabinet.
stays in the cabinet and everything.
I've never seen one attached like that. Sounds almost like maybe it's just put on with, are there bakelite or pins that those rivets attach to?
Possibly, I'd have to take a look. It might be something I can bring in next month and things, but.
That sounds almost like a T-nut over a pin that's molded into the cabinet. And with those, you can usually, the cheapo deluxe set of pick tools that you can get from Harbor Freight that has the orange handles that we all have like a million sets of. You can take a couple of those that are the 90-degree things and just sort of walk those things off of that metal pin.
Okay.
Or off of that bakelite pin. Or that's the way I do it. Yeah, I think you can also squeeze them in such a way, but it's so easy to snap those pins off on the cabinet. Of course, if you do that, you can usually super glue them back in place. But usually what you want to do is, prise that where it's pinching that bakelite up, and then you can sort of walk that piece off. I think it's called a T-nut or something like that, or a tri-mount or something like that, that's just holding onto a pin, and that's just sandwiching that plastic.
It's more like a push pin, but it's twisted into the plastic.
Yeah, it kind of looks like a metal washer, these little tabs.
Yeah.
The problem with that, a lot of times getting something out like that, say like a knob in front of a radio, itself, you're pulling, and if you put a screwdriver or something on one side, it makes it harder, but I just, on the radio knob, I got two.
Yeah, kind of uniform.
Well, I got two, big tablespoons, and I go over to it, take the knob off, do them both sides. At the same time, with a rivet like that in there, you
I'm thinking of. If you try and pull on both sides, it just makes those things pinch that pin tighter. That's why I say you gotta take those little pick tools.
And it'll come out and you're not gonna crack it. Not everybody has 2 tablespoons. Well, I keep in my shop all the time laying there because, well, we're not that wealthy, right? And you don't mark the front of the unit either, because you just work there. You might as well tear the unit nose.
And squeeze them.
Yeah, the plastic tile cover itself is all kinds of cracked and yellow and deformed, so that's the first time I've ever got a plastic tile versus all the standard glass one on the older sets.
Bring the cabinet in with you next time.
I agree, yeah.
Yeah, and
That's what
then
I'm
we
saying.
can see exactly what you're talking
Well,
about.
he gave me his card and I gave him the email to him and everything, he just didn't have that specific size. It's almost like a 5-inch square that's bubbled out.
You need to order it now, because he's gonna
Yeah, he's-
stop the end of July.
What?
Yeah.
Yeah, unless you wanna buy the business and take it over.
I think
I'm hoping he's found a seller. I'm hoping he's found.
I saw something that he said he found somebody to.
Oh, good.
But I don't know if it was, if it was the cover business or the 3D printing or what, but he,
Well, there's plenty of guys doing 3D printing. so
yeah,
don't worry
he
about
said
that.
he had
It's the
somebody who
cover
was gonna
business
train
that's
him.
gonna need somebody
Yeah.
to take over.
Yeah, I'll put it on my priority list.
Yeah.
You can take over his business for him.
Yeah, somebody younger taking over.
That's what I
we
thought,
need.
yeah.
I remember
Some
years
guy
ago-
that'll outlive all of us.
I remember years ago when I seen a cover bad on the radio, and I'm like, how am I gonna remake it? And I tried to heat it and everything. But he come up with a really good deal, you know, heating, having all the molds. And every time I tried it, turned out to be a mess.
Yeah, me and Charlie and David Martin did some successfully. But it's a pain in the butt making a mold each time you need it.
Yeah.
And he's the one that, and a couple other guys around the country, but Mark's the only one left making it.
I remember just taking something from the grocery store and cutting it and trying to make it, mold it, and,
Or just trying to find a blister pack that was close to what you're looking for.
All right, yeah, definitely bring it. That's even better, so. Anythings? I'm still trying to get the screws for my, radio. I spoke to a gentleman, it was actually, you gave me the name, can't think of it now, but I contacted him, he said he's scrounging around, he thinks he can get it. It was not the photograph shop, it's the other guy. Real friendly guy, always helps, can't think of his name, got it for me, but anyway, so hopefully I can secure that. So just FYI, I have my great-grandmother, I think like 7 great-grandmothers,
DM audio enthusiast, Gary Stark, maybe?
I don't remember, I have a senior moment.
Phonograph guys, I think, Summers or something.
Yeah. An old photograph, it was Polk Audio were made in,
Are you talking about George?
yes, George,
Yeah.
that's him,
Oh, okay.
right. That was in pieces, and I'm trying to get it back together from my mother-in-law, and
George's got
you
50,000.
can't get the parts anymore, and Polks were assembled by, you pulling stuff from other boxes, right? And
The
so,
only problem with George is he's in Florida all the time, and he has his grandkids, go to the warehouse.
it could be worse. So I'm still trying to get that done. She's never seen the thing run in her entire life, so I'll make points if I get the thing.
George is down there.
And you have been instrumental, like no tomorrow, in getting me stuff, because he's got all kinds of phonograph things, and I got arms and whatever, turntable things and that, and so thank you again for your help. Anyway, okay, that's it. Then let's go to our show and tell. The topic this month
I
was,
can do your show and tell. I'm gonna be your man.
you're my Vanna? I like that idea. Ms. White, if you will approach the table. This topic today is homemade homebrew radios. And it's funny, I got a note from Jacob. He goes, can I bring a homebrew amplifier, like I assume stereo amp? And I said, sure, for $5 I'll bend the rule for you. So he was going to bring it, but he didn't show up, so
I need the microphone.
you'll get the mic. I got to turn the camera around.
Yeah, micro.
Okay, this one over here is Danny. You want to come up here and explain it?
Well, I can tell you, the box was a radio kit that we put together when I was in high school.
I'll
all step to the side so that,
the classes had the choice of either the Packard Bell or one of those gray marks. And I chose Packard Bell, even though it was dated, but it had a cabinet, and it looked better than the gray mark did. My actual radio I have assembled, working, it's somewhere in my house, I don't know where it is. But the last time I did run across it, I pulled the instruction book out and put it with that unit. That was something that came from either an estate sale or maybe one of the swap meets. It's about 90% complete, but it's the same chassis, but it doesn't have the cabinet or the knob. On the bottom of the box, it's got a date of 1947, so Packard Bell apparently made that available for a long time. And there's two SAM schematics there of virtually the same radios that they manufactured with the same chassis and sold as complete radios. And the other little unit in front of it was just something I put together in the early 60s to plug my record player into and have a choice of AM radio or the record player. But that, I had just graduated from breadboards to bud aluminum chassis. And that was one of the first things I made with an aluminum chassis.
so you punched all the holes in it now?
Punched all the holes, drilled, yeah. It's very crude, but like I said, the dynamo labels are at least still sticking to it after 60 years.
Now those punch holes look like it was drilled and then filed out.
Some were. We only had two sizes of punches for me to use. Luckily, the tube sockets, the IF transformers, and the electrolytic all fit with one.
Uh-huh.
But everything else had to be kind of drilled and then reamed out to the correct size.
Uh-huh.
I
And-
think it's very crude, but again, I was just a kid.
Yeah, and it's pretty nice because it's got bass and treble.
Where did you get the 70-25?
I don't know.
Yeah, it's obviously a 12AX7, and that tube was released in 1946, so it's,
Well, like I said, at the time, I just put in whatever I had available. I used the 12AX7 rather than the 12AB6 because I wanted the extra stage of amplification because I didn't have the separate bass and treble controls on it. So
Oh.
it's basically a 5-tube radio, but with a 12AX7 instead of a 12AB6.
Now, why is there a diode across the off on? Oh,
I didn't want to wait for the tubes to warm up every time I turned it on.
oh,
I instant on everything in my parents' house. Their 5 radios, my television, my 8-kit stereo, the car. My father never caught on even with the power bill. And everything was instant on in the house.
oh, be darned. Huh. That's fascinating. Never seen that done before.
You can't copy it, Roger.
So you're running the filaments on DC, in other words, until you turn the power on.
Well, when you turn it off, you get minus or a negative 50 volts across all the tube filaments. And there's, it doesn't pass through the rectifier because it's
Yeah.
minus.
Yeah.
And when you turn it on, then it shorts the diode out, you get your full 120, and then your rectifier works. You can't
Uh-huh.
do it with a power transformer set.
No warm-up.
Yeah, you can do it with just a AC/DC
I'll be.
television or radio,
Huh.
with just a diode.
Wow.
You need to give it a thought.
Well, I learned something new. And this is Reed Fisher's. And Reed Fisher will talk about his 2-tube radio. I thought it was a transmitter at first when I looked at it. He had to correct me. And I don't know if it's super heterodyne or what.
Let me
I don't
say
think so.
a few words about it. Let me have your transmitter.
There you go.
Okay, this is a copy of the National SW3 receiver, which came out in the mid-1930s. Since I couldn't afford a National SW3, I built one, a copy of it. It's a 3-tube receiver, a 6J7 RF amplifier, a 6J7 regenerative detector. Have you ever worked with a regenerative detector? What a challenge. You get the thing very near oscillation, and suddenly the gain goes way up, and the Q gets very high, so the tuning is very sharp. And then the output tube is a 6J5. The thing has plug-in coils, so you can change bands. I believe this is on the 80-meter amateur radio band, not the broadcast band. Any questions?
Still use it?
Yes. It plugs into a general radio power supply, those little cubic inch box things. So I believe it still works. Of course, headphones only and no loudspeaker.
Too bad you don't have a diagram for it.
Somewhere I have a diagram.
Okay, and this is one of mine over here that, I don't know if any of you have already seen the video, which I done sideways, by the way, on this one, on the Crosley 52 radio. But anyways, it is working now. That was donated to me by one of my customers. Says, "Oh, you want a radio?" I says, "Oh yeah." Well, it had one tube in it, and the tube was no filament in it at all. So I was looking for tubes. I didn't have any spares of the 01As or 201s or whatever. And the only one that was in it was a short pin one. I thought I needed a short pin one. Well, you know, the locator on these, you can use the long pin because this pin here that locks it in is moved, and I'm a dumb. I didn't. But anyways, yeah, you can't know everything every day, I guess. But,
You talked to Aries, I thought you had some.
yes, well, I did go to Aries' house and get a tube. I actually went to one of my Bremen Tully kit radios I had since I was a kid, which I put on display, I think one time in the club meeting, and I had it operating on batteries. Same thing here, I could have this operating on batteries, but I got this little handy dandy power supply, so I operated on it. But the only tube that was left in this thing that had open filament, so I needed 3 of them, was a short pin like that, see? And this one is in 20, that's 01 or whatever, 201s, 01s, you know, UVs there. But if you look at the brass pin on the side, they're in a different location. So that's, I learned something myself again. That no, you don't need a short pin tubes. And instead of $2, I had to pay $15, by the way.
Still a market.
Yes, because if you look on the internet, UV 201s or UX, blah, blah, they go for around $30 to $50, generally 50 if they're good.
I think I've got a few
But,
of my own, and
yeah,
we could work a deal with
well,
them.
yeah, now I took the 2 spares out of my kit radio. They were backup and put them in here. But, you know, this is your band switch. Now, this is regenerative. And like he said, you get a tremendous amount of gain with it. But, you know, your tickler coil is here. This is your tunable, and it's a book capacitor. It opens like a book. So that's how you tune it. And this is your band select. This is your off-on. This is the filament for the RF stage, oscillator, and so on. If you look here, that does the RF stage. And this is your audio stage. One of the guys, well, he's got a 51. And it's a 2-tube. This is the next version. If you look at this on the diagram, if you put your headphones in here, which you have to use high impedance headphones, not 8 ohm or anything like that. And when you go in here, you just got the front end, you got the 2-tube radio. You go over here, this is your, where you put your high impedance reproducer or speaker or whatever, but it's got to be high impedance. This would, your B plus goes through here, your 90 volts, and you get your audio tube. So it does have an audio tube, so you can get a little more gain for a speaker or reproducer or headphones. So it's, when you go in this stage, not as much audio, you go to this stage, less audio. So it has an audio amplifier in it. And it's nice and clean, and it's very light and portable. Handy dandy little thing. 1924, it's got a date inside that somebody put 1925. Nice condition. But anyways, if you're interested, you can look at it. You can see here that you've got a 2-tube radio when you put your headphones there. And anybody needs any high impedance headphones, I got boo-hoo. Lots of them. With quarter-inch jacks, pin jacks, whatever. And there you go. Thank you.
All right, I think that's about it. Next month, Harry, member of the month, you get to hear his deep, dark secrets and his questionable past and whatever things that he did. Show and tell, portable TVs. Now, portable is a relative term. If you really want to schlepp that 36-inch portable console in, you go have a good time. But there are plenty of pseudo-smallish portable TVs out there to bring in. Next meeting is on July 1st.
July
11th, I'm testing you, and you all passed. Congratulations. You're paying attention. For the next month, I will, as I said, work with Aries to get our, hopefully, October 13th date for the next, almost at Hamfest, swap meet, and get that going. Again, Facebook. Welcome again to the new members. Anyone have any questions, anything, thoughts, opinions? Yes, sir.
We talked about oscillator instruction at some point.
Yes, so the idea came up, which is great, was having oscilloscope, demonstration on oscilloscope. And Mark was going to be an integral part, but so I wanted to do it for this month, but he wasn't available. So we are trying to do it technically. I've played with next month or so. The answer to your question, yes. But it may be also a situation with a couple of people, because I know Paul's, it's like different people have different pieces of the puzzle. And so I'm kind of working that through, but we will absolutely do it. But I know Mark was an important one, he was not available. So again, if you go out to the Facebook site, there's a calendar there. That thing is always up to date, because if I don't put it out there, I won't remember it, that's for sure. But you can always see who's doing what, when, and where. And it does move, it does change a little bit, it's fluid. But once we get that baked, of course, it'll be on there as well. But yeah, I'm interested too, because I don't know squat about oscilloscopes. Plugging things in. Why is it smoking? I have done that. Anything? Good? Okay.